Hello, this part will be going over the Pentagon mill project that you'll be doing for App 7. To me, it's kind of a little bit of an interesting part, more so in the calculations of the tangent points, probably more so than the actual machining of it. It does bring up some challenging mathematical skills that you need to bring on from your calculations class from your second semester. But so as we look at the part, the first thing you're going to notice is our numbers, okay? Not your typical numbers that you've been seeing. Oh, I'm sorry, not that. Okay. Notice down here in our title block, and it's in millimeters, okay? Very common in industry to have parts or prints in millimeters. There's two ways you can go about doing this. You can program your program, that made sense, in metric units simply by using a G21 in the safety startup line. That's for metric units. Normally we see a G20 for inch units in that safety startup line. This works it works fine. Probably in this case for programming it's probably actually easier because all your numbers are in metric units. But the problem comes about when you actually machine the part and you have to make sure your part is to print. Now, unless if you have metric micrometers, maybe a metric digital caliper you may have, but once again, that's not really suitable for tight tolerances like this. So you end up having to convert these dimensions over anyway. So what I usually tell students is just to convert them over, convert all your dimensions over using the 25.4 conversion to get into inch units. That way you write your program in inch units, you're familiar with the units. When you're running your program, you know what those dimensions are. When it comes down 180, you know it's 180 versus maybe 3 millimeters. So the number's a little bit more familiar to you. I've had students do it in metric, and I can't think of one that really wasn't kicking themselves when they were machining it, thinking that they should have converted everything over to inches. So like I say, that's your call. We'll work with whatever you decide to do. So either way you go about it, the programming is going to be the same. Okay. Once again, the first operation you're going to do is face off, establish your z equals 0. Okay. So you face it off, establish that. So once you have that done, you basically have 1, 2, 3, 4 features that you need to machine out. The way I would go about it is I would do the outside first and then work your way in. Work your way into that, do that circle. So this would be first, that would be second, the Pentagon would be third, and then at the teardrop I call it, you would do that the fourth time. Okay? So if you go about it that way, you're going to be doing this first, that depth first. I would do that in probably 3 passes, 3 Z passes. Divide that up, 18 millimeters I believe is around 700, maybe a little bit more than that. So you're going to take that down in 3 passes. So once you have that done, you have this outside done. And from here, the part is actually programmed that this here is less than a ½ inch. Okay, that's your biggest gap that you'll need to cover. So you don't have to worry about your end mill coming around and leaving the area that won't be machined. So if you just machine the features, you're going to be just fine. So you don't have to worry about making extra passes to clean material up on the outside. So you got your start point. For the outside, it doesn't really matter. What I suggest you do, though, is you keep the same start point for whatever you do. It just makes life a little bit easier. So let's assume we're going to start up there. So your first feature, you're going to be coming down, your G41 right there, coming around. But remember, when you cut off, when you come off, you want to ramp off and then do your G40 and then wrap it back to your start point for your multiple passes. It's important that you ramp off so you can complete this arc. So you're going to do that 3 times. So okay, so now we have that done. We're still going to keep our same start point, and now we're doing a circle. But now this time, we're going to do our G41 to that point. You come across G01, you do your arc, cut off, G40, wrap it back to do your next pass. Okay, you can do that in one pass, even though we're going to be taking 9 millimeters, or whatever that may be. You can take that all off in one pass. Okay, so we got the circle done. Now we're into our pentagon. So we're going to come to this point, G41, and once again, cut all the way around, come up, come over, G40. Okay, you kind of see the pattern here. You hit your point, cut off, cut through the part, G40, back to our start point. Okay, so that's our pentagon. So now we're down to just that teardrop. Once again, you're going to figure out what this point is. You can very easily figure that off from your radius. G41, you come to here, to here, to here, up, up, G01, G40. Now here there's no need to go back to our start point because we're done. Okay, if you happen to copy and paste and you go back there, I guess it's no big deal, but you really don't need to. What you need to do, you do need to cut off and then G40 to cancel your cutter comp. And once again, you can do all three of these in one pass, okay, and it'll clean up all that material. And that's pretty much your program. So you're only going to really have three tools. You have your face mill, your high-speed steel rougher, and your half-inch carbide. And so that's all you do. So the programming part itself isn't all that big. But there are some things you need to figure out before you really start programming. Okay, you have all your tangent points. Obviously that outside feature won't be that difficult. Nothing you haven't done before. Okay, once the circle shouldn't be a problem. You have your radius that's called out up here, actually a diameter, it's called out up there for your circle. We do have the pentagon. Okay, one thing you have to remember with the pentagon, they all come off that center. So if you remember from your calculations class, all of these arcs should be the same, or they need to be the same. Okay, they go to the center point of that pentagon and out bisects those angles, those intersection points. So all you need to do is take 360 degrees divided by the number of angles. That'll get you this. And from there, you should be able to figure this out. And all of a sudden we have a trigonometry problem that looks something like that. Once again, you can figure out what your radius is off of the diameter. Okay, so you know this length, you know this angle, and this would be your y then, and this would be your x. This point here, just by figuring out these angles are all the same, that angle will be the same as this angle, so that point will be the same. This one here, you can kind of go about that same way. You got a triangle right here. Okay, you know this. Shouldn't put a question mark there, but you know what this is, and you know the angle. It'll be half of whatever this is, and then you can figure out your numbers. So that point would be the same as that point, vice versa on your y's. Y's of polarity would be backwards. So that would be your pentagon. So that leaves us only with that teardrop. So there's really 2 points, well 3 points if you start up here. You have to figure that point out, but that's just your simple radius. Okay, 35 millimeters, whatever that may be, calculated out. The other points you have to figure out are that one and this one. So this one here, you have this little triangle like that, 6.5 degrees. Pretty straightforward. Once again, 35 millimeters. So you should be able to figure out your x, and then that would be your y. So that point shouldn't be that much of a problem. Now you have this one. What people want to do, and for some reason they assume that if this is 6.5, this is going to be 6.5. That is not the case. Okay, you can't just assume that. So from here, what you have to do is you just have to basically start writing down what you know, and you work your way back. Okay, I'm going to erase some of this up in here. Okay. So I have these tangent points. I have these two lines that come from one point and they're tangent to that circle. So what that tells me is that these lines are equal. I don't know what their distance is, but I know they're equal. Well, if those lines are equal, that means that this angle has to be equal to each other, because that line bisects that intersection of those two lines that are tangent to the circle. So from there, you should be able to just figure out, kind of start writing numbers down, what you know. You're going to be using this angle from your Pentagon. That's going to help you. So you go through and just kind of calculate it out, and once you find out what this angle is, then all of a sudden then you can figure out your X and your Y. Okay. What I do recommend you doing is, before you start writing your program, find all your tangent points. Okay. Find them all for the Pentagon and the teardrop at least, and then come and see me and we'll verify your math before you write your program. That way, if you come up with errors as far as I's and J's, or bad arcs, we know that your math is correct and it's a programming error, versus then we have to go back and try to troubleshoot your math or your program. So we can eliminate one of those issues when you start writing your program. Another thing I do recommend you doing is when you start doing this, grab a couple sheets of this print. I'll make a number of copies, because it does require, it gets messy if you just do one print. Some people, what they'll do is they'll grab like 3 prints, and they'll have one print that'll have the numbers for the Pentagon. You know, they'll label them, they'll do whatever, okay? And then after they figure out the Pentagon, they'll grab another clean print, and then they'll do the numbers for the teardrop. And that does seem to help a little bit. So once again, do the math first. Come and see me. We'll make sure your math is right. If you struggle with finding a number, once again, come and see me. We'll help you through it. Other than that, good luck, and we'll see you in class.